Hi, I'm Paul Stringfellow and welcome to the latest in our Gardner Tech video series. On this episode, we're going to be taking a look at a challenge that I've seen affect enterprises through the entirety of my IT career, and that is managing distributed storage systems. How do we effectively share files among multiple locations in many geographies, and how do we do that while maintaining efficiency, control and security? We're also going to be taking a look at how that challenge now is stretching into a wider one of how we start to integrate something that is very high on the agenda of pretty much every enterprise we speak to, and that is public cloud, and how we get public cloud integrated into our traditional IT storage infrastructures. So to do that, we're going to be taking a look at a new technology from NetApp called Global File Cache, and helping me to explore that is Jaap from NetApp. So hi Jaap, how are you doing? Welcome to Gardner Tech Videos.
I'm doing great, Paul. Thanks for hosting this call today. Nice to meet you. Super excited to talk to you a little bit more about Global File Cache today. Just a little background about me. My name is Jaap from Duijvenbode. I'm product manager with NetApp, based out of Amsterdam, the Netherlands, and working closely with the NetApp ecosystem for the last couple of years. In my 20 years plus IT career, I've been, to your point, facing similar challenges with regards to organizations that are dealing with the challenges around distributed storage, want to modernize the way that they kind of put it all together and manage those assets, streamline infrastructure. So today I'm super excited to talk to you about that, what that looks like in the context of the public cloud and the NetApp solutions offerings that are available today.
Well, thanks for that introduction, Jaap. And I think, again, you touch on a couple of things there straight away that I probably did put in my introduction around how that idea of sharing data over wide areas has become a challenge. And again, no surprise to people. We're recording this in May of 2020. So, we're still operating in a world very much affected by COVID-19. But I think that's brought very much and sharply into focus the idea of where public cloud and the ability that public cloud gives us to share data over wide areas and make that data sharing more straightforward, more usable, has real benefits. So, but maybe to start off then, Jaap, do you want to kind of give us a little bit of an insight into how you see the market right now, how you see some of the challenges in terms of sharing data and moving data into the public cloud, and then we can start to kind of investigate some of the ways that NetApp are helping customers to overcome that.
Most definitely, Paul. And I think what's super exciting, even though we're in this situation today where most of the workforce is working from home, I think the problems and some of the reasons for organizations to kind of relook or re-architect the way that they manage storage is more relevant than ever before. So what I'm seeing in the market is that a lot of organizations, they have shifted from this traditional way of managing storage, silos of data, file servers at the edge in branch office environments. They're trying to look at that in a different way. They put a different pair of goggles on and they say, well, how do I kind of modernize the way that I deal with that storage? How can I bring it central? How can I drive cost efficiency? How can I benefit from the elasticity and the scalability that the cloud provides, which is something I really see as a paradigm shift. Especially in the small mid-market, that's where a lot of organizations are now moving into the public cloud from on-premises environments. In the actual enterprise, we see it's more of a journey. Customers have already touched upon hybrid cloud integration. They're now touching upon moving workloads into the public cloud, first SaaS, then PaaS, and then the largest chunk of them all, which is IaaS workloads and storage. So that's what we're going to talk about today in terms of how Global File Cache plays an instrumental part in that cloud journey for customers to be able to benefit from those the solutions that are available.
I think you bring up two really useful points there as well. That part of the introduction, obviously, we're talking about a technology called Global File Cache. That this is very much not just about the idea of being able to share data across multiple locations, geographically widely spread. This is also, and for me, certainly, I look at it as a very interesting step for those customers who are looking to start to bridge that move into public cloud. They want to use public cloud. They see that as part of their long-term data strategy for all of the benefits that it brings, but might be right now thinking, well, how do I get my data into the public cloud? Like you said, how do I take advantage of all of those cloud capabilities while maintaining a lot of the enterprise controls that my organization demands? So I'm really interested to see that. So Jaap, fire away.
Yeah, I'll fire away. And I think I'm really happy to talk about data strategy because, a lot of organizations that we talk with, they've been accumulating and facing exponential growth of unstructured data in their environments for many, many years. So I just wanted to touch upon a few reasons why customers want to modernize the way that they manage distributed storage. The way that I see them typically, they're twofold, right? So on one side, you have the IT teams that are responsible for managing silos of data in branch offices or even in cloud or remote locations, manufacturing sites. That's one problem. And on the other hand, it's the business impact as well, where if you are siloed as an organization, or if you grow by mergers and acquisitions, or adding plans, or expanding the workforce in different types of areas, whether that's within robo sites or whether those are in VDI farms, because we're all working from home now, you need to find a way to kind of create that data portability and that manageability of the data where, as a user, I don't really have to care where my data resides. What I need is consistency. What I need is the ability to access that data in real time and the ability to share that data in real time without losing data, facing data integrity issues, all these things. So if we look at the IT impact, what we typically see, due to the excessive data growth and the duplication of data, we find that a lot of organizations are just throwing storage at the problem, at the edge. Windows file servers, NAS devices. They're trying to manage that storage in an efficient way by having local backup, maybe data replication for consolidated backup. But overall, that traditional model really remains complex. So the end result for IT is that it results in a complex IT management infrastructure. It's not really streamlined based on today's needs. And then from a business perspective, if organizations haven't been able to centralize their data as of yet, they actually are managing, or they're working on silos. So, I may be working on one version of the document, you may be working on another version of a file, whether those are typical Microsoft Office files or large complex engineering documents or CAD drawings or 3D models or very complex data sets. So we really focus on those two aspects, the IT impact of managing islands of data and the business impact in terms of being able to guarantee productivity and facilitate for data portability and mobility from that perspective. So what are the use cases, right? So when global file cache was introduced in the NetApp ecosystem, we've identified 3 use cases. Over the last 10 years, I've worked with organizations to help them in the journey towards centralization and consolidation of unstructured data. Some of the largest firms, architectural, engineering, manufacturing companies, they came to us and they said, Jaap, I have the need to better manage my data. I'm losing data because I haven't been able to bring up resources in my branch office sites because of a server failure, because of a WAN outage, because of issues with regards to the manageability aspect of that storage. So the primary use case we're focusing on is the ability to facilitate and leverage the cloud for a single enterprise data footprint, to allow to centralize all your unstructured data into the cloud, and then bring the data back to your users using caching technology, global file cache. The second use case that we see now more than ever is to facilitate for integration with VDI environments. And VDI in the context of leveraging the cloud for expanding and the elasticity of ramping up virtual desktop services, ramping up VDI clients, but at the same time bringing data close to the users in those regions. So you can think about organizations that have a cloud data center in East US too, and they may have users in Japan that need immediate data access to the data that is stored on the other side of the world. You can tell those users to RDP or set up a VDI connection all the way to the East US, but if you move the mouse, it takes a couple of seconds for that to reflect, right? So you need to make sure that, first of all, your application and your VDI experience is optimal, and then you localize the data as much as possible through the caching technology. And then final, what we're seeing as a use case is large file collaboration. Like you said, Bo, global file sharing or global file access, the ability to provide for a single namespace and a single set of data so that you can actually move your workforce around. If you have a project in APAC, you can use resources in EMEA or in Americas to be able to contribute to the project deadlines and the project flow. So those are the 3 key tenets that we recognize where global file cache not only fits those use cases today, but have been for the last 10 years. So with that said, I'm now going to dig a little bit deeper in terms of the technology. Any remarks from your end, Paul? Anything else you wanted to touch upon before I dig in?
Yeah, I made a couple of notes actually while you were talking that really struck me, and I think that the 2 things that really strike me with that, one is the idea that it allows us to have this kind of single version of the truth with data. And I think one of the things that we often see, and I think, as you know, particularly now, more and more organizations are recognizing this, is some of the difficulty that comes with sharing data over large geographically spread workforces. We can potentially have this issue where we are not all working on the very latest version of this data. It might depend on the latest update I got, or whether somebody's updated the copy that sits in SharePoint, for example, if I'm offering some semi-structure to the data. You know, and I think that's become a huge issue. And that idea that that public cloud gives us that ability to have one big repository where it is absolutely the single version of the truth, and just sharing versions of that out with remote users wherever they may be. I think that's hugely important for the way that organizations and enterprises operate, and the importance of their kind of business workflow. And I think the other thing though that really strikes me with this, and something that I'm very keen that we talk about with our customers all of the time, is this idea that when we're planning our data infrastructure, our data platforms, is that we take a focus that is data focused. You know, we don't build infrastructure, present that to our enterprise, and then say, put our data on that and see how we get on. We think about, what do we need from that data? How do we want to use our data? How do we want to be able to access that data? And I think technology like this and the use of public cloud to help drive it absolutely allows us to focus on that. You mentioned a couple of times, you know, as a user, I'm not really bothered about how the infrastructure works. All I'm interested in is, can I get the information that I need to be able to get? And I think technology like this allows us to do that extremely well, because it takes away lots of the focus on the infrastructure and the underlying hardware platforms and locations, and just allows us to focus on how we want to use our data. So yeah, they were just a couple of the things that really struck me in the way that you kind of positioned where Global File Cache sits.
Yeah, exactly. And I think one of the things that I'd like to focus on is because this technology is so mature and has been proven over the years, it also has proven to NetApp and the NetApp ecosystem and its customers that the solution transparently fits into those environments. And I'll touch upon why that is. But before I get into the nitty-gritty detail, there's a few things that we focus on as Global File Cache. Like I said, we're software-based product. We're focused on the Microsoft enterprise in a way. So it's a Windows-based technology that allows to consolidate remote or branch office data into the public cloud. So what does that mean? If you think Windows, you think Windows file sharing, you think Explorer, you think the flashlight, that's the SMB protocol. That's where the SMB protocol kicks in to provide access for your users to their shares, their file shares, or their centralized data. The SMB protocol is not designed to operate on a wide area network. It is highly subject to latency, and it really becomes painful to kind of access data if you have some sort of distributed environment. If you're confined within your local office and you have one single server, that's just fine. But if you have some sort of regional deployment, some sort of globally distributed organization, that's where SMB is really painful to operate over the wide area network. So Global File Cache really focuses on streamlining the way that the SMB protocol facilitates for Windows file sharing. And as a result, you can now move that data centrally, and you use intelligent file caching technology on top of Windows Server to be able to bring the data close to the users so you can achieve optimal performance. So the cool thing about our technology is the way that it's architected, it's cloud platform agnostic. You know, as you may know, NetApp has a wide variety of hyperscaler partners we're working with, Microsoft Azure, Google Cloud, AWS, and we have all these offerings in the marketplace that are available today. Cloud Volumes ONTAP, Cloud Volume Service, Azure NetApp Files, a lot of cool stuff that can do a lot of different things. Some of those platforms are more built on the fundamentals on ONTAP, data ONTAP, where you build out your own data fabric. Others are more offered like a service, like Cloud Volume Service or ANF, that are natively available in those marketplaces. So either way, the Global File Cache technology is a cloud platform agnostic technology that overlays on top of that infrastructure and creates what we call a software-based fabric. And the software runs on Windows Server, so it's really easy to adhere to all of the principles around the SMB protocol. So we natively integrate with SMB, all the protocols, all the versions, all the dialects to supply for all of that, all those applications that require access at the edge to be able to facilitate data access for the users, to provide for file locking, to provide for data consistency, and all of those principles associated. So what Global File Cache does, it provides your users a transparent experience in those branch office locations, and those could be miles away, through a global namespace with real-time global data access and central file locking. That, as a result, is going to allow you to not only centralize the storage, but also the ability to kind of achieve that performance aspect that's required for not only your users' data, like home drives, folder structures, personal data, but also project data, collaborative data, where you require all your teams globally to work on at the same time. As a result of doing that, and as a result of using caching technology, as opposed to putting local servers or local storage in those sites, you're drastically reducing your distributed storage cost. And why is that? What we find is that when we're talking to our customers, Paul, 80% of their their data sets is unstructured, but only 10% is really active at that time. So if you really look at the active footprint, it's a small chunk of data that is actively used. So if you're using intelligent file caching technology, you would only supply for what's really active. So you don't really have to worry about adding storage at the edge. You don't really have to worry about continuously provisioning for the incremental growth of storage over time and those requirements associated. So that's where Global File Cache fits in. It's a Microsoft-based software technology that sits on Windows Server, that deploys in the cloud next to your central storage platform and deploys at the edge in your robo site to be able to access that data transparently in real time.
I think what's, again, some very interesting points in there, and so a couple of things again struck me from that one. Certainly that simplification and cost reduction. I think for a lot of enterprises who will be watching this video, they will be thinking, yeah, we're keen on cost reduction, we're keen on simplification, because I certainly know from experience and some of the customers that I've spoken with who have large estates of storage arrays spread across multiple locations, across multiple countries, that comes with a cost, that comes with a complexity, that comes with a management overhead. And already those companies are starting to look at technologies such as this to talk about, how do I utilize, we talk a lot with our customers about this idea of tactically using public cloud. So to use public cloud where it makes sense, and to use public cloud to do the things that we find difficult to do on premises. And actually one of the things we find to do difficult to do on premises is the idea of sharing data across multiple locations, because not everything, for example, can go and live in a SharePoint site inside of Office 365, because not every integration, not every front-end software application will be happily talking to a SharePoint library. So you're always going to maintain that requirement to present SMB type access to files. It's hard to replicate that data across multiple locations. And I think this is a fantastic example of tactical plays its parts, because cloud is really good at doing that. Cloud is good at geographically spreading data. It's good at giving access. It's good as acting as a single point of truth for as a single data repository. So I think they are that idea of simplification, and that idea where public cloud is doing something that it's designed to do, and extending our capabilities of our traditional on-premises infrastructure, where it's actually much more difficult for us to do this kind of thing on premises and stuff. So again, just a couple of things that really stood out for me before we get into kind of demonstrating how the service operates.
Makes a lot of sense, also. And I will touch a little bit upon what that fabric looks like shortly, and then I'll roll into the demo. So the way that Global File Cache integrates in the customer's environment is you deploy what's called a core VM instance next to your centralized storage, and then you deploy an edge instance in your distributed sites, your branch office, manufacturing sites, even remote construction sites, where a lot of customers in the construction business benefit from, to ensure that data is available to them locally. So the way that Global File Cache works, you deploy those two software instances, one core, one edge, or multiple edges, typically in a hub and spoke manner. So the idea is to centralize. You could have one or multiple data centers, but typically what we find with customers, the idea is really to centralize and allow distributed locations to access the data from the cloud data center in real time. There's two intrinsic parts that sorry, let me rephrase that, Paul. There are two intrinsic parts that play a part in that whole ecosystem. It's a virtual file share and an intelligent file cache at each location. What does that mean? So you could have a petabyte worth of storage, But if you consider only 10% is active, maybe 10 terabytes for the whole, or 100 terabytes for the whole organization, you may have a small branch office, robo site, that only requires access to a small chunk of data. So we're really focusing on the active data set. So if the active data set is a terabyte for those sites, you'll just provision a terabyte worth of storage. If you have a larger site in New York or Amsterdam, wherever in the world, you just size the cache any way, shape, or form you want. It runs on Windows Server, so you can size it any way, shape, or form. So we deliver two things, like I said. We deliver a virtual file share, and we deliver an intelligent file cache at each location. The virtual file share is a file share that's accessible through a UNC path, or a drive mapping, or can be embedded within a domain or DFS-based or domain-based DFS namespace. So you have a globally unified namespace for data access. All these pieces are fundamental and native to the Microsoft ecosystem. And as a result of being able to achieve that, you enable a high-performance experience at the edge, because your users will interface with the edge as if it's a local file server, but with the consistency of a global file system, a centralized data set. So what does that look like from an architectural perspective? Like I said, most of our customers, they choose or opt for a hub and spoke model. On the right-hand side of this diagram, you'll see a centralized storage platform. In this case, I've opted for Cloud Volumes ONTAP. Cloud Volumes ONTAP is a great solution that's available within the NetApp ecosystem that allows not only to build a data ONTAP based storage infrastructure in the cloud, but also facilitates for business continuity, disaster recovery by supplying fundamentals such as high availability, DR within the region, or even cross region, where you can snap mirror data between different cloud regions to facilitate for disaster recovery scenarios if an entire data center in the cloud kind of vanishes off the surface of the earth. In addition to that, Cloud Volumes ONTAP is designed to transparently overlay additional services. So if you're looking at global file cache to extend the data to your branch offices, that's a great use case. If you're looking to integrate cloud compliance to get visibility in terms of what data is stored on your Cloud Volumes ONTAP infrastructure, that's a great solution. If you want to integrate cloud backup or SaaS backup or any type of technology, you can overlay that transparently onto Cloud Volumes ONTAP. So on the right-hand side, that's where your central data management resides. That's where you carve out your disks, you specify your aggregates, you set up your tiering, you identify your volumes, you set up your file shares, and you're managing your permissions and your ACLs and your permission structures like NTFS permissions. Next to that data, you deploy what's called the GFC, or the Global File Cache Core Instance, which can be seen as a traffic cop that just mounts those central file shares provided by Cloud Volumes ONTAP and extends the data out to the edge in your robo sites or your branch office locations. So the core instance is fundamental when it comes to being able to mount to that central storage that provides for subsequently for streaming, compression, optimization between what's called the edge and the core over the wide area network to not only overcome the chattiness of the SMB protocol, but also facilitate for compression, delta differencing, only sending the changes back and forth over the wide area network, and streaming of the data. So if you have large amounts of bulk data being written, we're streaming that effectively without any deprecation or without any impact of the SMB protocol, because we're localizing SMB at the edge between the user's desktop and the local edge instance, and we're talking SMB between the core and the Cloud Volumes ONTAP instance. What's in the middle is what's called the GFC streaming protocol, which facilitates for all the optimization that takes in place on the wide area network as well. And then on the edge, obviously, like I said, our software runs on Windows Server, and it hosts the global file cache volume. Can be any shape or size. It's an NTFS volume that we carve out. The virtual file share is visible as a UNC path, which I'll show you in the demo, and can be embedded within a global namespace. Subsequently, because the software runs on Windows Server, you can coexist with all your additional Microsoft services, roles, and features that you may require to run your edge. So if you have a requirement to facilitate for SCCM software distribution at the edge, you can happily coexist all those roles together with global file cache to create that unified footprint, like the good old branch office in a box, right? So, and that's what we're going to focus on in the demo. I'm going to show you briefly what that infrastructure looks like. how you configure your core instance, how you configure your edge instance, and subsequently, how do you access the data in a centralized fashion? Is there any difference? What are the performance benefits I'm getting? And what is the experience from a user's point of view?
And I think what again really stands out here is that, and again, a note I've kind of made while you've been talking there is about how seamless this is as well. You know, this is I think often that we consider when we're looking at public cloud that there's going to be a lot of refactoring of the way that our applications work or the way that our workflows operate. And actually for a lot of organizations, that's also a blocker. That's also stopping them making that move. They may see the benefits of public cloud, be that for scalability, cost efficiency, availability, you know, whatever reasons they might be doing that, but they look at the complexity of that move and some of the risks that they may be taking, you know, that they may lose some of the enterprise quality capabilities that they get in their on-prem data centers. They may lose that inside of an Azure or a Google Compute or an AWS. But what this is showing me is that this is a lot more straightforward. We are taking a seamless extension of what we do on-prem and being able to utilize public cloud where we see fit. And actually from a day-to-day operational point of view, we're not really seeing any change. And I think that's hugely powerful for those organizations who are looking to take that step into public cloud, who are looking at a way of how do I bridge what I do traditionally in my data center with all of the capabilities that public cloud bring me. And I think a solution like this, it really opens up some possibilities for an enterprise.
Yeah, I agree. And I think, you know, now that we're ready to get into the demo, I'm going to skip this, Paul, by the way, this piece. You can cut this out. This may be a little bit too technical for the audience because it talks about the whole bucketing least recently used mechanism. Yeah. So let me move to the actual demo. What I've done is, in order to keep things really simple, I've put in a demo lab infrastructure in Azure. I didn't integrate with CVO or ANF or CVS. I wanted to show something that is kind of transparent or storage or cloud agnostic from that perspective. If you have any need to kind of look at how does this integrate with ANF or CVO on Cloud Central, there's a number of videos available that allow you to see how you provision file shares and volumes in the cloud on CVO or ANF or CVS. This focuses more around how transparent is this, right? How do you stand up an infrastructure that is a central file repository? How do you source data into that? Do you just copy paste it? Do you use robocopy, or are there additional tools that you can use? And then subsequently see how transparently the technology automatically discovers those file shares and makes them available at the edge. And subsequently, I'll show you how users would interface with a file share, how users will open up a file through a virtual file share, a namespace, a drive mapping, or whatsoever. And then subsequently touch upon some of the benchmarking results that we've often captured with customers that say, hey, we've tried to move our data into the cloud, but our users are complaining because they're 200 milliseconds away. So how do you capture that? What are the performance benefits that we're seeing? What can you expect? And then if we have time, we'll talk a little bit about, you know, troubleshooting analysis and what that looks like. But first of all, what I've done, and in order to elaborate on what we discussed, where we have a centralized storage platform, which is called the backend file server. That could be Cloud Volumes ONTAP, Cloud Volumes Service, or ANF. Then you deploy the GFC core instance on a Windows Server VM next to that central repository, in this case, in the West Europe Azure data center. And then you deploy your GFC edge instance, and you have your Windows 10 clients on the left-hand side in your robo location access that data. In this deployment, because it's a lab environment, what I've done, I have set up VNet peering between two different regions, West Europe and East US. And in East US, there's another GFC instance deployed. That is the central management server. And that central management server doesn't only facilitate for the licensing and entitlement, but also helps with the orchestration and the building of profiles and setting up specific policies that apply to your GFC infrastructure as a whole. Now, this is based on deployment of Windows Server instances in the cloud and overlaying our software installation package on top of that. We also have available templates, virtual templates that you can deploy that have either Windows Server 2016 or 2019 embedded with the actual GFC software. Going forward, and this is a sneak peek, in the next couple of weeks, we will be releasing integration with Cloud Manager, where those VMs that you can see in the picture on the right-hand side will be auto-provisioned using Cloud Manager as if it's a SaaS offering that you just turn on in the cloud through Cloud Manager infrastructure. It automatically associates with CVO. It automatically stands up all the resources required. So that's super exciting from what's coming. Now, the thing that to understand is like some terminology that I'm going to use the term native file access, which is basically users from the robo location on the left-hand side, could be, let's say, UK, accessing data directly on the backend file server. So those users are typically subject to latency, bandwidth restrictions, spotty connectivity, or whatsoever. Then we're going to use the GFC core instance, which mounts to the centralized storage. The GFC edge instance actually facilitates for the local cache and connects to the GFC core to provide seamless data access to what's centrally staged and what's centrally managed and maintained. And then the Windows client I'm going to use just as a Windows 10 client with Office 365, Word, Excel, PowerPoint. I'm going to show you how users would interface with that data and how they get access to the data as a whole. But before I go there, on the right-hand side, on the backend file server, you can see my backend file server happens to be Jaap-core/share West Europe. So what I've done is I designated the core instance to be a backend file server as well. Normally you would have a CVO instance, ANF or CVS, but in this case, I'm going to tell my core instance that the core is a backend file server with a number of file shares. So in order to access data directly into the cloud, you would navigate to the UNC path Jaap-core/share West Europe. In the edge, though, we create what's called the virtual file share. And the virtual file share is used to interface with a kernel driver that interoperates with a user mode process that allows to effectively stream and compress the data between the GFC edge and the GFC core. So that virtual file share allows you not only to associate with your Azure data fabric, so your GFC fabric that I've defined in West Europe, with the backend file server that I designated, Jaap-core, and the central file share West Europe, you can also fan that out. So if you have multiple geographically distributed sites or even multiple data centers, you can associate this single edge instance not only with a core in West Europe, but you could also associate that with a core instance in Australia or in East US. And then you create this reverse or this fan out architecture where all of your assets, whether that's your fabric association, different regions in the cloud or even multi-cloud, and then subsequently your backend file servers. So in this case, we have one backend file server, but you could have multiple. And your central file shares could be one to many as well. So you could create a global namespace that really aggregates all of your geographically distributed data centers into a single namespace at the edge. And that's why that virtual file share is really important to understand, because if you type in this UNC path in Explorer, you would end up in the exact same space as if you would going to Jaap-core/share West Europe. But now you're accessing that data locally through the cache. So with that said, I'm going to touch upon a few scenarios. Like I said, some of the considerations and prerequisites. I have deployed a Windows Server or Windows 10 client. I have deployed what's called an edge instance on Windows Server, and I have deployed a core instance. Paul, can you see my desktop? Can you see my remote sharing session?
Indeed, I can, yes.
Beautiful. So let me start with the core, because the core sits closest to where the authoritative data resides, right? So we're centralizing data into one or multiple data centers. For each data center, you deploy core instance, and you basically associate that core with the backend. In this case, the backend is the core as well. So what I've done in what's called CIF service configuration or SMB service configuration, I added a new backend using generic SMB, and I added the Jaap-core backend server to mount to. So now my core instance is mounting to itself to allow the file shares that are local on this core to be presented out to the edge. If I look at my actual physical disk, or my logical volumes here on this Windows Server VM, you can see on C drive, I have a number of folders, and I have created a data folder that has share West Europe. So in Share West Europe, I just put a bunch of dummy data. Folder 1, folder 2, Office Bench, and sample data as an example. This is just your average backend storage platform. This is where you migrate your data to, either through copying the data directly into the folder structures if you have small amounts of data, or using technologies such as NetApp Cloud Sync, where you can move multiple terabytes or even up to petabytes worth of storage into a centralized repository on Cloud Volumes ONTAP. Cloud Sync will then handle the data migration using the data broker and synchronizes the data to your central file repository that now becomes the actual central authoritative data set. But for this test, I've just created 4 different folders, and by mounting this core instance to itself, it allows the edges to subsequently discover those file shares. So this is literally a process that takes 5 minutes to configure. You spin up a VM, deploy the software installation package, you license it, and then subsequently you associate it with your backend server target. Now you're done deploying the core instance. The next thing is you take your VM template, or you take your software installation package, you go to your remote site, your branch office site, where you may still have resources. You may still have infrastructure available. Your customers may have Hyper-V or VMware, or have bare metal to install the software straight on top of. You can do that. It's easy. So what you do now is you deploy the edge component of our software. It's the same software installation package, but the installation process, the configuration process is a little bit different. So now instead of going to deploy, or basically deploying this instance as a core, I'm going to deploy this as an edge. And the only thing I have to do after licensing it is I have to associate it with our Cloud Fabric ID. And the Cloud Fabric ID, and I hope you can see it, otherwise I'll zoom in a little bit, is Azure WE, which is Azure West Europe. And I'm going to associate it with the FQDN of my core. So now I'm going to connect my edge to the core so they can talk to each other. And my core talks to CVO in the backend, or in this case, talks to itself as a backend server. And my edge now has connectivity, is connected to the actual core instance to be able to show me those centralized file shares. Once this is done, I can actually see the data that is stored on my backend storage platform. For ease of use, I've created 2 drive mappings here. I created an N drive, which is native, which is directly to the backend. So I'm now sitting on my Windows 10 client, and I can see all the folder structures. Now, because this infrastructure is confined within a single cloud region, this performance is still pretty okay. But as soon as you're going to introduce latency, we're all familiar with the flashlight, we're all familiar with the non-responding message that you get in the Windows Explorer window if you have latency, or if the SMB protocol actually gets host from that perspective. So natively, I got a number of folders, I get a couple of documents that I've created, and I got some sample data as well. These are Word, PowerPoint, and Excel files that I stage centrally. So what does that look like if I'm in a remote location? And for that, I've created a separate drive mapping. And that drive mapping is called the G drive for GFC. And as you may be able to see on the G drive, you can recognize that UNC path structure, Jaap edge, / fast data, / Azure West Europe, / Jaap core. So now what I'm seeing is I'm seeing exactly the same structures. I'm seeing exactly the same files. Everything happens in real time. But the only difference I'm seeing is because this thing is just deployed, I'm seeing little cross marks on the files that are not cached. And the cross marks on the files that are not cached represent the offline attributes. That means that the metadata is available for that file, the ACLs are available, the extended attributes, all that cool stuff, but the actual components, the contents of the file is not there yet. So if I would click on one of these files now, the global file caching technology comes into play. The user requests that file from the edge communicates with the core instance and requests that file from the backend, where it takes a central file lockout. It streams and compresses the data over the wide area network, serves it into the cache, and basically opens the file from a user's perspective. So within a few seconds, if everything is woken up again, I think it should show that this file is being opened and the data is warmed up as well. So this is a typical Word document, right? So PowerPoint, Excel, CAT files, anything that has external references or depend on linked files or Excel macros, all of that stuff is transparently integrated. It works out of the box. Is not, you don't need to change anything in the way that you're managing your storage or your data. Complex applications like AutoCAD, like Revit, Bentley MicroStation, those applications will transparently honor all the principles of the actual SMB protocol. So now what I've done is I opened the file for the first time, caching to place, served me the file to the user. So what I'm doing, I'm going to make a few changes, test, and I'm saving this file back. So the central repository of the data still has a central file log. So if I would now open up a file on the other end of the world, I would get a message as a user that, hey, this file is in use by Jaap. Do you want to get a notification, or do you want to read a read-only copy to work with? I can actually demonstrate that. And the way that I demonstrate that is I'm going to basically I'm now going to access the same file directly from the actual backend. So now the file is in use by myself as a user through the cache, and I'm going to basically open up the same file, and what I'll get is I'm getting a message that sample doc file is locked for editing by Jaap and Duijvenbode. You want to open up a read-only copy, create a local copy, and merge the changes later, or receive a notification when the original copy is available. And I choose the latter one because I want to know that once I'm done with the changes that I made prior, I'm going to get, the latest and greatest changes, right? So I want to make sure that I'm not overwriting someone else's data. I want to circumvent issues with data loss or data integrity. And I also want to make sure that, look at this, file is now available. So the file is available for editing. So what I do is I'm opening it for read-write. What happens? I get the latest and greatest contents right here in the file. It is file sharing. I get it. It's not Kubernetes. It's not all the sexy stuff that we see in the marketplace, but it's very essential for a lot of enterprises to work with. So global file cache is really designed to create that transparent experience when it comes to accessing data. And obviously, as you can see, I have a very low spec Windows server or Windows client as well. So, in that sense, your performance will be optimal when you spec it with the right resources in the cloud as well as on premise in your branch offices. But this is a quick demo in terms of.
Well, I was just to say, yeah, I think what's really powerful about that demo is it goes to show as well that how efficient this is as a process, because to be able to do that, we're not replicating copies of data into multiple locations. We have one copy of the data. We're using the metadata to present a version of that out at our kind of cache point out of those remote sites. And then we're only needing to call that data from its central repository as and when we need it, and I think for anybody who, as we talked about before, for anybody who is trying to share data across multiple locations, the traditional approach has been, I'm going to put lots of storage repositories in all of those locations and find some way to move my data around. For in a NetApp ecosystem, maybe that's using something like SnapMirror to move data around. Whereas with this, we're just moving the data as and when we need it. We're not copying terabytes of data to multiple locations that we don't need, which opens up all kinds of issues around security and efficiency of the way we hold our data. So, I think that's a great example of just how efficient this is as a way of sharing data and utilizing cloud again to do something that actually on-prem is quite difficult for us to do.
Yeah, it all looks and feels, to your point, Paul. It looks like a global file server. It looks like your traditional file server, but now on a global scale with the ability to get that performance and that experience at the edge while reducing the footprint required. Right? So in terms of storage capacity and capacity planning and the ability to kind of have optimal RTO and RPO. If you would lose an edge today, it would take you days or weeks to restore that because it's localized, right? You have a local file server, you got to find a backup, a USB drive maybe in someone's desk to restore a backup from last week, which actually failed. So you have to go back a month. So you lose data. We see that all the time. We see a lot of customers that still manage that data in a siloed fashion with all the ramifications of that. So now if you lose an edge, you don't lose any productivity. Your users will automatically be able to fail over, and that's what we use DFS namespace for, to the central repository. So they can continue to work. They continue to kind of have their productivity. So the RTO and RPO is kind of less than 5 minutes for the users, instead of sometimes weeks to be able to restore a server infrastructure at the edge. So that's a key critical aspect. It's not only about streamlined storage management and facilitating for better integration when you're mergers or merging or acquisition or acquiring companies, but it also facilitates for better RTO and RPO from a user's perspective. So a lot of different things. I know we're coming up to the hour. There's one more thing that I wanted to briefly show is creating a new backend file share. And what that means is whilst you're continuing to manage your storage and infrastructure, obviously you'll have different types of storage tiers to work off. You know, some of it's primary disk, some of it's SSD, HDD, and some customers are using Fabric Pools technology to tier data off to object storage as well. What that means is that based on the data retention and the age of that data, it tiers data off to cheaper or lower cost storage. The way that we overlay that is in a transparent fashion. You know, everything still looks and feels like a traditional file server infrastructure because all of the performance and the IOPS you'll derive and your users require, they get from the edge. And if one way or another your data is tiered out, you still get that performance. Or if you're using standard HDD in the backend to reduce cost, you can still do that and you still have the performance at the edge because that's where you get your performance from in your application experience. So now if I create a new folder, I'm just going to call it Pulse Share. And I'm going to use the traditional way of sharing this out through Microsoft Windows Explorer. And obviously, depending on the backend platform of choice, you have different mechanisms to do this. With ANF, you use the Azure portal, the resource manager. With CVO, you'll basically log into Cloud Manager, and then you manage your CVO instance and your working environment. And with CVS, kind of in a similar fashion, you manage that through the respective hyperscalers portal. But now what I'm doing is I'm just creating a dummy file share. And now I go to my edge, which sits on the other end of the world, right? So if I go access the data, and this has mounted to Share Europe, but if I go to Jaap Edge, I will see my Azure WE repository, which is my fabric. I can notice my Jaap-core backend file server. And if you watch closely, and we'll refresh this for a little while, you should see this new file share show up in a second. Pulse share, there it is. So now I've provisioned a whole new share with all kinds of different parameters, different backup snapshot policies, whatever I require from that perspective. And it's transparently visible and accessible from the edge within seconds, which makes it really strong in terms of helping you to kind of facilitate for consolidation of file server projects that encompass consolidation of file servers, migration of data. If customers are not ready yet to kind of restructure the logical organization of their data, they can still move their silos, but in a central repository to ensure productivity and to facilitate for better data management. Other organizations, they may be ready for restructuring the logical way that the data is represented as well. That means that if you have digital workplace transformation projects, if you have specific workflows that you need to adhere to, you can use DFS namespaces to subsequently build these file shares into a single namespace that not only reflect the physical structure of the data, but also reflects the logical organization of your business going forward. So that being said, I think we're coming up, benchmarking results. I'm just going to show you a quick example of what we typically see in terms of organizations that have tried to move data into the cloud and the performance that they were getting. This is pretty usual what we're seeing with our customers, where red is the data access over the wide area network. Blue is the initial caching and compression and streaming that will take place. And green representing file opens and file saves whenever the data is cached. So if you don't have any caching methodology in place and you think, hey, I'm just going to lift and shift this workload into the cloud, the red is what you can expect. You can expect that you have to wait 70 seconds, 80 seconds for a file to save back to your central cloud repository. That's why you need GFC, because we're localizing that user experience. We basically allow for write-back capabilities when your users are saving files. So basically, if your users are saving a large 300 megabyte file, that file writes at local speeds. It may take some time for the file to reach its final destination, but the write happens at local speed, so your users can continue to work in any way, shape, or form. And the same thing applies for reads. The initial read benefits from actual compression, data reduction, and streaming of the SMB of the protocol, eliminating SMB chattiness. And then subsequently, when it comes to saving, we're only sending the deltas across. So we don't send the whole file or the compressed version of the file. No, we're only looking for the delta blocks to move over the wide area network. And that's how we get to these numbers. So if you want to get to a close, a local type of experience, but with the consistency of a centralized and global model, this is what you can expect from global file cache.
I mean, I think with that as well, and I think what's interesting about that graph is if you are prepared just to work with kind of the native capabilities, the native performance, that what we're doing is we're making a decision about how our data is used based on the infrastructure and location where we've placed it. We have not thought about how we actually want to use the data and the user experience. We've made a decision based on we want to put our data in the cloud, and we're not really considering the impact of doing that. And that's the complete opposite to what we talked about right at the beginning, which is technologies like this, in my opinion, for an enterprise, are a great way of designing your data infrastructure with data at the core of your thinking, not infrastructure, not location. I think if you fail to do that and you're prepared to accept the kind of performance metrics that you can see on this graph, then you're deciding that the other way. You've decided that the way your infrastructure works and the location of that infrastructure is the design, is a design model that you're working to, and the user experience and the way the data and information is being used is only secondary in your thinking. And I think actually for a modern enterprise, that's not the way to design a data platform.
Exactly. And I think, lifting and shifting is not the approach, right? So we see a lot of customers that they thought they could just move using site recovery, move VMs into the cloud and let all the problems vanish, right? It doesn't exist. The cloud's there to supply for flexibility, scalability. To your point, like I said earlier, putting a different pair of goggles on and look at the world differently, because it is different and it's going to be different in the future as well. The way that you not only access data, the way that you manage it, the way that your users are integrating complex workloads. Some of our customers are using drone images or video footage that they capture from construction sites. They need to not only process that, but they also need to edit that. They use 3D rendering or farms in the cloud because they want to be able to scale up, NVIDIA Grid Series VMs to kind of do rapid rendering of large amounts of data. Some customers have laser scanning applications that just spits out hundreds and hundreds of gigabytes and terabytes worth of data within minutes. So you have to be able to deal with those requirements, those very extreme scenarios, but also still be able to facilitate for scenarios that are very common, that have been common over the last 20 years, your typical Office files, your typical file shares, your PDFs, your image libraries, anything you can think of, but will still be relevant in the future as well, because there's a place for document management control. There's a place for enterprise file share and sync if you're small businesses, for example, and there's a very big spot in the enterprise for better managing unstructured data and providing data access. Yeah. So with that said, I think I wanted to give you a sneak peek on what the technology looks like, how it's implemented, what it facilitates for. We can dig into a lot of other feature function. Because it's Windows Server based, like I said, it's very easy to manage, very easy to deploy, very easy to consume. It fits within your existing management framework. So if you have Azure Log Analytics or Azure Monitoring or even SCOM on premise, you can manage all those assets from your operations management perspective and treat it like an extension of your Microsoft ecosystem, but with the actual resilience and the maturity of the NetApp data fabric behind that. So I'm super excited to be part of this ecosystem where we can really focus in on that use case and focusing on almost like the missing link for NetApp to be able to facilitate for these use cases in the Microsoft world.
And for people who are looking at this, is that what's how do they go about purchasing global file cache? Is there a way they can test it out as well?
Yeah, definitely. So basically, we have if you want to have more information, where to go next? Cloud Central is your point of repository. That's where you go and you can inquire. You can work with our sales team. You can Look at the website for more information, demos. Soon we'll have a lab on demand infrastructure available for customers and yourselves as well to be able to benefit from. And in the next couple of weeks, we will make further announcements with regards to the integration with Cloud Manager, which is going to be super exciting. For now, navigate to Cloud Central, fill out the form, and we'll contact you, have a discussion, and we can help you set up a pilot infrastructure to test the solution in the customer's environment or in your environment. And maybe we'll speak again, or one of my team members will be able to help you out as well. So that's where you go. We also did a webinar on April 1st, which sounds like a long time ago, but it's only like a month and a half ago now, with a large SI, Accenture. And we work closely with Accenture and a very large German food processing manufacturing technology supplier that has approximately 2 petabytes worth of storage from 280 locations to be moved into the cloud. And we've done a webinar to explain what that journey looked like. Not so much a product pitch, no product overview, but really what is, from a process perspective, what does that journey look like in terms of sourcing resources, the ability to quantify how much data needs to be migrated, finding the right vehicles and mechanisms to kind of supply for that data migration and everything associated. So that's where to go next.
Well, yeah, I think that's been fantastic. I think it's a real interesting technology. For me, there's probably 3 things I take away from this. One is that this kind of technology absolutely solves a real problem. I think for many of our customers, who we talked about at the beginning, I've worked in this industry for around 25 years. And this kind of problem has been a problem from day one and continues to be a real challenge for businesses and only a growing challenge, as we have more and more data and more requirements from it. I think it's a great example of tactical cloud use. I think it's the idea of we're exploiting public cloud to do the things that we find difficult to do on premises in traditional infrastructure. And perhaps most importantly, it's simple. It's something that people can deploy. It doesn't cause them to have to hugely re-architect their environment. It doesn't have to cause a change in workflow. It's a simple deployment that's giving you access to some real powerful capabilities. So yeah, really appreciate you sharing your time with us. And I'm sure if people have questions, they can follow up in the ways there. Of course, they can contact Gardner Systems and their representative at Gardner Systems. But for now, yeah, thanks for being on this Tech Video Series show, and we look forward to welcoming you back some point in the future.
Sounds great, Paul. Thank you so much for hosting.
If you do have any questions, then contact the team at Gardner Systems. We'll of course be happy to help. We do hope you found this tech video useful, and do look out for future tech videos coming soon, and you'll find them on our website or via subscription on our YouTube channel. So until next time, thanks for watching.